Alright, so we're going to simplify radicals, roots and radicals again, and we're going to talk about maybe simplifying some little more complicated stuff. So we're going to again remember that we've got the multiplication property of radicals to help us out to kind of separate and conquer. If I've got a product in here, I can rewrite that product as a perfect square times something else. 100 is 25 times 4, and all we're doing is first step is rewrite whatever's inside the radical, the house. 100 is 25 times 4. 25 gets its own house, 4 gets its own house. 25 just happens to be a perfect square, and 4 just happens to be a perfect square as well. But the idea of this is to rewrite that 100 as 4 times whatever is left over, because 4 is that perfect square, or 25 times whatever is left over. So let's take a look at, we took a look at perfect square numbers. We took a look at perfect square variables. Perfect square variables have exponents that are even. Took a look at simplifying some of this stuff. Took a look at simplifying some of this stuff that was even more complicated because it involved numbers and variables. And the next step would be to take a look at something that's got maybe something that's inside of a house and see if we can simplify. If we see something like this with a fraction inside the house, see if you can simplify whatever's inside the fraction first, or inside the house first as the fraction. So if I take a look at square root of a to the 5th over a cubed, well, a to the 5th over a cubed is, oh, I don't know what that happened there. We'll keep it as blue. We'll keep it as blue. Thank you. A to the 5th over a cubed is, square root is still there. A to the 5th divided by a cubed is a to the 5 minus 2 is a squared. Oh, wow, look at that. I got a perfect square. We could have separated and conquered up here, but that's a separate chapter. It's a chapter coming up. But if I take a look at this and I say, well, maybe we got a fraction in here, simplify the fraction first, and then take a look at simplifying this. Because now the square root of a perfect square means the base, a, comes outside the house. There's my answer, a. Done. I got square root of 9 over, I got square root of 6 over 96. Well, 6 and 96 can kind of simplify. Square root of 6 over 96 is, sorry, 6 over 96 can be simplified to 1 over 16. And you could simplify by canceling out a 2, canceling out a 3, and you get to 1 over 16. All right, well, 1 over 16 is, square root of 1 over 16 is 1 over 4. Because you could say that square root of 1 over 16 is, well, let's see, let's go the long way here. Square root 1 over 16 is 1 over 4 squared. And then square root of a perfect square means the base comes outside the house. There's our answer, 1/4. Over here, yikes, this one's a little bit more complicated, but again, we've got this whole thing here that says let's simplify that. 27 over 3, now let's see, I'll put the big square root here. 27 over 3 and a divided by sign here. 27 over 3 means I've got 9 here, because 27 and 3 can cancel to 9 over 1. X to the 5th over x is x to the 5 minus 1, because there's an unwritten 1 that's down there. I've got to the 4th power, x to the 4th power over 1, because everything canceled out down here and left just a 1. So clean it up here. This would be 9x to the 4th power, square root of, and now hey, all we got is perfect squares. So I'm going to separate and conquer. Square root of 9, square root of x to the 4th. Square root of 9 is 3 times, remember all this is multiplied together. X to the 4th is x squared squared, because we're looking for those perfect squares. It's a perfect square, but if we rewrite it as a base squared, then we can take the square root of it. Square root of a perfect square means the base comes outside the house. I've got an x squared there. I've got a 3 times that, and there would be our answer. A lot easier than looking at square, simplifying this and simplifying that. Yikes, what a mess. Same thing here. I got square root of y to the 11th over y to the 3rd. Let's simplify that. Y to the 11th over y to the 3rd is y to the 11 minus 3 is 8. And put it inside the square root. That parentheses simplifies to the y to the 8th. And now I'm going to rewrite that y to the 8th because it's a perfect square already. Write it as a perfect square, as a base squared. Square root of a perfect square means the base, y to the 4th, comes outside the house. Done. Last one, I guess. Well, let's see. I got, let's see, 1 over 4, z. I think that should be my answer right there. See if you can get to that one. Yes, 4z should be my answer. See if you can get to that one. All right, what do we got here? All right, simplifying square roots. Okay, wow. Well, let's see. This one would be the last thing we can do is kind of take a look at this. All right, what if we've got 5 times the square root of 20 over 2? Yikes, what a mess. Well, what we can do is say, you know what, let's take a look at square root of 20. Maybe separate and conquer, and I'm just going to look at square root of 20. Square root of 20, and I'm going to maybe simplify that. Square root of 20 is, let's see, I'm going to rewrite it as a perfect square times something else. Does 4 go into 20? Can 20 be rewritten as 4 times something? Yeah. Square root of 4, square root of 5. Square root of 4 is 2 times square root of 5. So this square root of 20 is square root of, or sorry, is 2 square root of 5. So I'm going to say now this is going to come down here, and I'm going to say, you know what, all I'm going to do now is just substitute that 2 square root of 5 instead of square root of 20. So I'm going to say it's 5 times square root of 20. Well, let's call it 2 times square root of 5. Ugly square root of 5, sorry. Over the original 2. And now everything's a factor. 5 times 2 times square root of 5 over 2, everything's a factor. Now let's see what we can cancel out. 2 divided by 2 is 1, so that's a factor, and factors cancel, factor out, simplify, reduce. And now what's left over? 5 times the square root of 5 in my numerator, and the denominator, make sure that's a 5. Denominator is 1, so we don't really need a denominator. So there's our answer. So just look to simplify that square root and put it back up into our original statement and see what cancels out. 7 square root of 18. Well, let's see. Square root of 18. Square root of 18. Let's see. Rewrite that 18 as a perfect square times something else. I know there's a 9 in there. 18 is 9 times 2. Still inside the house. Square root of 9 gets its own house. Square root of 2 gets its own house. Square root of 9 is 3. Square root of 2. So square root of 18 is 3 square root of 2. Now let's take this and rewrite it. 7 times the square root of 18. Well, instead of the square root of 18, we're going to rewrite it as 3 multiplication square root of 2 over original denominator 3. See what cancels? 3 divided by 3 because they're both factors. Factors cancel, factor out, reduce, and simplify. Same word. Different words are same meaning. What's left over? 7 square root of 2. Done. Alright, ooh, how about this one? 2 minus square root of 36. Well, don't be alarmed by that square root of 36 and the subtraction sign, not yet. Because if we can simplify that, we might be able to make it easier. 2 minus square root of 36, well, square root of 36 is 6 over 12. Well, let's just simplify this. 2 minus 6 is negative 4 over 12, negative 4 over 12, negative 1/3, done. Alright, 5 plus square root of 49. I'm going to give you the answer, and you can come up with it. See if you can get to there. 2. And there's my answer.